Hello, in this video we're going to work through this question. This kind of brings together all our ideas around the idea of transformations. And so we're going to work through this question right here. So we're going to start with the graph of y equals x squared. And using progression, graph y equals negative 3 x minus 2 squared plus 4. And we'll show the progression on the left and label each graph in the grid on the right. So when we talk about the progression, another way we can think about this is we could say, what are the transformations being applied? So when we talk about transformations, we want to think about two things. We want to think about what is it we're doing in words, and what is it that we're doing mathematically to each point. So if we take a look at this relationship up here, we can see it is a quadratic because of the squared, and there are four transformations going on. The first transformation is it has a reflection across x axes. And so what does that mean mathematically? It means we're going to take the y value and we're going to multiply it by negative 1. The next transformation we want to account for is we have a vertical stretch by a factor of 3. So that's what's happening in words. Mathematically, what we do is we take each y value and we multiply it by 3. And I'm going to put transformation 3 and 4 here on the same line. Is we see we have a shift 2 units to the right and a shift 4 units up. So we're going to shift right 2 and up 4. So that's the progression we need to go through from our parent graph of y equals x squared. So of course, when we do this, the first thing we want to do is draw that parent graph in. So by this point, we should be getting pretty good at visualizing y equals x squared and really quickly sketching it out. So there's y equals x squared there. This is our parent graph. So what I'm going to do now is I'm going to apply the first transformation to each of these points. So I'm going to reflect across the x-axis, meaning I'm going to multiply each y value by negative 1. So we'll do this in steps. Excuse me, we'll do this in steps. We'll make this a gray graph, and then our second step is going to be our vertical stretch. We'll make that a black graph, and then our last step is going to be a shift right 2 and up 4. Make that a red graph. So if we multiply each of the y values by negative 1, the vertex doesn't change. The point 1, 1 goes to 1, negative 1. Point 2, 4 goes to 2, negative 4. The point 3, 9 goes to 3, negative 9. And I could, if I want, work through each of these points individually, but of course I can also take advantage of this idea of symmetry. And I really want to stress that you don't forget about this idea of symmetry. It's very useful in a lot of things we do. It will allow you to check your work. It will allow you to work through questions faster. Really important not to forget the symmetry idea. So now we're going to apply a vertical stretch by 3. So that means if I have the point here, we're going to move from the gray graph to the next graph, which will be black. So this point is 1, negative 1, so it's going to become 1, negative 3. This point is 2, negative 4, so it's going to become 2, negative 12. And that's going to be right off the graph down here. And again, I can use the same symmetrical argument. So there's the second stage of my graph. Now, it's good to note here that I did go and actually plot these points on here, and one of the reasons is because I've looked ahead of my work and I see that I'm going to shift up by 4. So these points here, this point here, and this point here are actually going to shift back on the graph. So let's do both the shifts at the same time. So I'm going to take my vertex, which is here, 1, 2, and then up 4. Let's take this point here, 1, 2, and then up 4. Take this point here, 1, 2, and then if this is at -12, it's going to go up to -8. And then, so here is one branch of the quadratic. Now, I could of course transform this point here and this point here, but if I just kind of dotted my axis of symmetry here, I can very quickly 1, 2, 1, 2. And there's my resulting graph. Okay? So when we talk about a progression, what I mean is, can you give me the transformations that I have to apply, and in what order would we apply them? The key thing to remember when you're applying transformations are shifts last. Okay? Really important that you remember shifts last. Some people will learn a specific order, reflections, stretches, shifts, but again, it doesn't matter the order you do the reflections and stretches, you just have to remember that your shifts go last. So of course, now that I have this final graph, I can pull the vertex pretty easily off this, and I can see the vertex is at 2, 4. And you really want to make the connection here that the vertex can be read right out of vertex form. Remember, this is vertex form. So that's going to be 2, 4. Our max min value, well, this is going to be a maximum value because it opens downwards. We know it opens downwards because it has a -a value. And so the maximum is going to be at 2, 4. The maximum always occurs at the vertex. The direction of opening is down. The axis of symmetry is going to be x equals 2. Remember, the axis of symmetry is always the equation of a line, and if you notice, it will always go through the vertex. It's always useful to dot it in. And now we want to find the y-intercept. Now it just works out here that it happens to be that I can see the y-intercept from this graph. It's going to be 0, -8. But it's really important, let's put a star here, it's really important that we recognize whenever we're finding the y-intercept, we want to set x equal to 0 and solve. So if we do that, we see y is equal to -3 bracket x minus 2 squared plus 4. So y is equal to -3, 0 minus 2 squared plus 4. And of course now I could do a little algebra and I could get -8 pretty easily. Okay. One final comment. In class and in some of the videos we've talked about the 3 forms to represent a quadratic relationship. This form is called vertex form. Another form is standard form. One of the things we want to understand is what does each form tell us about the graph, and we want to be able to change between the forms. So standard form is the form y equals ax squared plus bx plus c. So if we wanted to, we could actually convert -3 x minus 2 squared plus 4 into standard form, and that would just involve a little algebra. Now I don't recommend doing this in this case because we do know how to find the y-intercept pretty easily. As well, it's on the graph, but it's just good to make this connection. So if we do this here, this just takes a little bit of work. Almost there. And notice this really nice feature about standard form. The c value is the y-intercept. So again, we want to talk about these different forms of quadratics, but specifically, what does each form tell us about the graph we're drawing? Even though here we've done a painstaking process of graphing each point, ultimately what we're interested in is the feeling of the graph, or what is the trend that is occurring. In understanding the trend in the shape of graphs, it means we can use them in a lot of interesting ways and get a better idea of how problems will work out. I hope this video helped.